Welcome to lab number 4. Today's experimental topic is free and forced convection. The equipments used in this experiment are our arm feel HT19 and our arm feel HT10XC along with a computer. Now the arm feel HT10XC is our computer control box or service unit. This is used to control all the instruments on the HT19. Now the HT19 is basically a rectangular duct that sits in a vertical position. It is fitted with a centrifugal fan at the base of the apparatus that pushes air through the duct. Now this air can be varied by adjusting a throttle plate in and out that allows the air velocity to vary. Now, as we go upstream, or downstream I should say, we have our flow sensor, which is this device here, and it reads the airflow in units of meters per second. Further up, we have our first thermocouple, which would be notated as T1, that provides us with the temperature for the upstream. Next, as we go up, we come across our plate heater that's pinned, and it's roughly about in the center of the trough. On our plate heater, we have a thermocouple that gives us the direct temperature of the plate heater, which will be notated as T3. Then we have 3 thermocouples on the center pin, and they're notated as T4, 5, and 6. T4 sits at 10 millimeters from the base of the plate heater. T5 sits at 36 millimeters from the base, and T6 at 62 millimeters. As we go further downstream, we have thermocouple T2 that gives us the downstream temperature of the duct. Now, all our thermocouples and sensors are also connected to our HT10XC, and this allows us to control the power supply to the heater and also to gather direct temperatures through the duct and also to pick up our air velocity within the duct. Now, from here, the 10XC is connected to our computer, and from there we can gather our data through the arm feel software. Now, let's begin the experiment. First, we're going to open the arm feel software. So now we have our arm feel software open, and you can see from the diagram it's illustrating all our readings. So here you find T2. Here you'll find T1, and here you'll find our flow velocity from our sensors. And also here you'll see our heater reading, the plate heater reading, and our 3 different thermocouple readings along the pin. So what we would do, we're going to turn the machine on. And first, what we're going to do, we're going to set the power to 60 watts. So the power is set to 60 watts. Now we'll allow for sufficient time to achieve a steady state condition noting that this condition can sometimes take up to 2 hours. Now, after we have reached a steady condition, we would take temperature readings of T1 through to T6, and we'll also notate the air velocity should be 0 at this point. So we would go over to go, and we check on our tables, and you'd see we'd gather all our readings, T1, T2, all the way through to T6. And also you can see here our air velocity is 0. Now let's get back to the diagram. Now, our next reading should be done at an air velocity of 1 meter per second. But before we go any further, we're going to be doing 4 different readings. First at 0, which we just did. Secondly, at 1 meters per second for the air velocity. Third, at 1.5 meters per second. And finally, at 2 meters per second. So we're going to be taking 4 different readings at different air velocities: 0, 1, 1.5, and 2. So at this point, we would go ahead and turn our fan on. Now, to turn the fan on, we would turn the switch. And to adjust the airflow, we simply turn this knob out to increase the airflow and turn it in to decrease the airflow. Now let's get back to the software. So now we have the fan on, and as you can see, our air velocity is 1 meter per second. It fluctuates a little bit between 1 to 1.1. And what we would do here, we would wait roughly 5 to 10 minutes for some amount of stabilization. And then we would go ahead and take readings just by hitting go. Now we have 2 datas, 0 and at 1 meters per second. Now we'd go back to our diagram, and now we would adjust our flow by turning the throttle knob to increase the airflow to 1.5. So now our airflow is fluctuating between 1.5 and 1.4. And what we do would wait again, allowing the system to be stable. And then we would take readings. So we took readings just now. So now we have 3 readings, 0, 1, 1.5. Now we go back to our diagram and adjust our airflow to 2 meters per second. So now we're fluctuating between 1.9 and 2 and 2.1, which is acceptable. So again, We would allow for steady state 5 to 10 minutes, and after which we would hit go again, go to our tables, and there you have it. We would have our 4 data readings: 0 velocity, 1 meter per second, 1.5, and this one was at 2.1, which we're aiming for 2. And as you can see, we have our T1, T2, T3, all the way to T6 readings, along with our voltage and current and power. Now at this point, the experiment is over. If you have any questions, you consult your Professor Dr. Whitworth, and thanks again for watching.